We are live. Eric, James, I'm Hugo, as you know. Great to see you both. I'd love to welcome everyone to our Coiled live stream today on first of the year on Is Spark Still Relevant? We'd love your thoughts in the comments. Introduce yourself. Let us know who you are, where you're tuning in from. James and I work at Coiled, where we're building products, services, all types of things for scalable data science in Python, built around Dask. Eric has just removed his Jeff Goldblum aviators. Eric, why don't you introduce yourself in 3 words? No, you can have more words than that.
That would have been an interesting challenge. You should have let me know that more than like 2 seconds ago. Yeah, so I'm Eric. I currently am director of data science platform at DTN, global weather analytics company. My day-to-day responsibilities are, range from, building out the right infrastructure to support a data science transformation at a $280 million company, to working with product to help them understand how to think about building, products that involve analytics to, fighting AWS, kind of all over the place. Before that, I was at Anaconda. I think I'm still rocking the hoodie. Yep, the Anaconda hoodie. Before that, I was in ad tech. And then before that, I got a PhD in chemistry. So, everybody's got a weird journey into data science. I am one of them.
Yeah. I went from pure math to biophysics and cell biology to doing a lot, like using Python and using IPython notebooks originally back in 2011 or 2012 or whenever it was. And then came to the Dask side, so to speak. I work in evangelism and marketing at Coiled. James, maybe you can say a few words about yourself.
Yeah, joining in with the story, I started in particle physics and ended up on the Dask side, as Hugo says. So I'm a Dask maintainer and the lead open source software engineer at Coiled.
Awesome. And we've got a few people in chat. Just want to say hi to Fabio, Scott, David, Christiana, Alex Remedios, Ray, Mark, David, Nicholas, Matt, all introducing themselves from all around the globe. Scott Barnett says, no, please put the shades back on. The future is so bright. Got to wear shades, Eric. So that's
said
great.
That?
Scott Barnett from the Northeast.
From Coiled.
Yeah, exactly. I love your framing in terms of the eternal battle against AWS, which provides great utility, but it's also the AWS is the closest thing in data infrastructure we have to the early internet. I feel in terms of how entangled it is and how challenging it can be to navigate. But I'd love to know also a bit about your interest in Python.
Well, that's a broad question.
Yeah.
I don't know how to answer that. I mean, it's a useful language. I like my interests in it. I like using it to solve problems. I like the I like the income that I'm able to get by being really good at Python and open source and data science.
Yeah, I think all those points are important. I think I think the utility of it, right, and the fact that I don't know, we've heard it described as a Swiss Army knife, right, where you can. It's not always for most jobs. It may not be the best thing, but it does glue everything together in a lot of ways. And
So Tom Caswell said once to me that it's everybody's second favorite language.
I love that. That's brilliant. So we have a bunch of people tuning in who are interested in whether Spark is still relevant or not.
Sure.
Now that isn't quite what we're going to talk about because it is still relevant in some ways and not in others, right?
Well, yeah. So this is a kind of a revisit of a talk that I gave in 2019 at PyData. We'll put the link in the summary blog post at the end, probably.
Yep. We will. We definitely will. So we're going to write a recap blog post, which will circulate and put a variety of links in there.
Yeah. So I would definitely give that a watch if you haven't yet. This is going to be kind of a new 2021 lens on that same topic. The original thesis was, of course, Spark is still relevant because it's everywhere and everybody's still using it. And there's lots of people doing lots of things with it and selling lots of products that are powered by it. So like, of course, it's still relevant. It's absolutely a clickbaity title. You know, in 2019, the question was, you know, the interesting question was, why are enterprises still choosing Spark, right? For those of us in the PyData sphere, we're like, hey, Python's so much easier to use than this Spark thing. You know, I like Python. I don't want to write Java. You know, there's a bajillion reasons that.
And I don't want to read Java traceback either. Right?
Sure. Yeah, like going as somebody who enjoys Python, going to Java, you know, meh.
Yeah.
You know.
And also, as we have a rising tide of Python users who may not be as programming literate, or they're learning, right? Like we have a huge long tail of data scientists busting out across all industries, right? So meeting them where they're most comfortable.
Yeah. So yeah, so I would go back and give that talk a watch because it gives a really good overview of kind of that question then. It was, you know, the talk that I gave then was really about Spark versus Dask versus Rapids and kind of, you know, what are these ecosystems and when do you choose one over the other and are they really equivalent? Yada, yada, yada.
I was just going to say, one of the things I loved about that talk, and one of the reasons I invited you here, is because you framed it in terms of what enterprise needs, in terms of business needs, in terms of business risk, quantification, management, and minimization. And I think the more conversations we start having, data science isn't only a technical discipline, right? And so the more conversations we have about tying data work to business needs, I think that the far better off we'll be. The other reason is you made almost a plea in that talk that one of the reasons Dask had not reached as much adoption as we would have hoped by that point is there weren't companies. There was no Databricks for Dask, for example. There weren't companies supporting Dask and building really useful scalable products around Dask. And that's something we're really excited to be doing at Coiled. So I think we're almost like our genesis is very related to the premise of your talk as well. And these are things I'd love to talk around today.
Sure. Yeah. Well, you know, you're welcome for making the business case for your company, I guess.
So let's jump in.
Sure.
Do you want to start with some whiteboarding or some slides, or what are businesses?
Yeah. So well, we'll get to that in a second.
Okay.
Before we get, well, yeah, we can hop around. Okay. So original title talk slide was this one, you know, right? Is Spark still relevant? The answer is yes. So pivoted to this. Again, go watch that talk. The new version of this is not why are enterprises still choosing Spark. It's really just what's the data science landscape look like now. I'd probably add another few words in here, which is kind of for scalable computing. Yeah. So
can you just tell us what scalable computing is?
Anything that isn't a single thread on a single core.
No.
You know, to various degrees qualifies. It kind of expands rapidly from there. You know, you could do local multi-core, you could do local single GPU, local multi-GPU, you could do distributed CPU, you could do distributed GPU, but that's that's not for the faint of heart.
No.
You got to have a pretty clear use case, and like you would never go from local single core to distributed GPU. Like that's like much too large of a leap. So, you know, really it's about the journey from going from local single core to something more than that, right? You can go to GPU, you can go to multi CPU, you know, from there you'd then probably go to distributed CPU. What's it mean to you, Hugo?
Well, all of those things. There's a common misconception that scalable compute is all about going to larger and larger data sets. And I think to correct that misconception, on top of everything you said, is it's to do larger workloads, larger models. I mean, hyperparameter tuning is one really, really important and naive example. And then thinking about essentially forms of complexity science in data science. So if you have a lot of different things you need to do in parallel or simultaneously, that's one very important use of scalable compute. Maybe James, as a core Dasker, can provide a few thoughts on what scalable compute.
Yeah, sure. I mean, sorry, I'm getting some notifications. Yeah, I mean, I agree with everything that's been said. It's, I don't know, it's somewhat hard to define in a single sentence. I know it when I see it, I guess. But yeah, I mean, scaling out to larger than memory problems, sure. Like you said, like we've Tom Osberger has given great talks on a library called Dask and SQL, where he talks about RAM bound problems, memory bound problems versus compute bound problems. I think that space is another good way to think about scalable computing as well.
Absolutely.
I'm just taking notes because this is an interesting conversation that I'm sure that we want to.
And we know the perils of live coding, but we haven't really encountered the perils of live slide writing, which I'm enjoying.
Part of this director role is getting really good at PowerPoint and like draw.io, you know, and
that's awesome.
My code skills are getting rusty, you know.
Right. So you had referenced, I believe, this slide, right? Yeah, this is awesome.
I think I might have some notes here. Yeah. So this is going to be useful. So there's some, you know, speaker notes at the bottom that I wrote for myself in November of 2019. Thank you, past Eric. You know, businesses care about, you know, things that we as, you know, folks that are interested in open source technologies and writing libraries and like software engineers and data scientists typically don't spend a lot of time thinking about the kinds of things that the business cares about, and are more interested in solving those technical problems. Those like, what's the right model to choose? How do I build my model? How do I get new contributors to my open source library? How do I, you know, build this API correctly? The business doesn't give a crap about any of those things, right? The business is there to make money. You know, the business is there to do things like identify risk, right? So minimizing the amount of risk in a project is a huge component. You know, I think that the example that I have down here is that, you know, if you've got a project that could take between 6 to 18 months to implement, are you going to pick that or one that, you know, will definitely take 9 to 10 months? The ability to plan is absolutely critical. And, you know, part of identifying risk is into helping the business plan, right? Because if you take the context of this is a data science project and we could have it done in 2 quarters or 6, we have no idea. There's getting the data science piece answered is only one step in a very long chain that includes, you know, product taking it to customers and validating the thing that you've just built. You know, that's the next step that then you'll probably need to go and tweak your model again based on the customer feedback. Assuming that feedback goes well and that product can, you know, sign some customers, you've now got to involve marketing and sales and customer success and the leadership team. And there's so many downstream things from any sort of successful data science R&D project that, you know, the more that you can de-risk or the better that you can plan, you know, the more the business is going to be interested in the solution that you're putting out there.
And the need to de-risk, I suppose, is one of the reasons that Spark is still relevant, right?
Yeah, like Spark is the new IBM, right? Like you're never going to get fired for choosing IBM was, you know, a phrase in the 70s, 80s, and 90s. I mean, hell, it probably is still a phrase now. Yeah, and like in the context of using something like Dask or Rapids, like any good CIO or CISO or CTO is going to be like, cool, how do I get support for this? Like, I hear you when you tell me that my team of 15 to 50 data scientists wants to use Dask, but what do I do when you leave? Because you know Dask, but nobody else does. Like, how do I pay somebody to de-risk the situation? You know, and that was one of my pleas that you had referenced earlier of like, where are the Dask companies? Like, we need companies that will provide services around Dask or tools and products around Dask. That's really why companies were still choosing Spark over Dask in 2019. I think we're making some inroads there with Coiled, with Quantsite, with kind of the Saturn. Don't kill me for saying that name here, Hugo.
Not at all. Great.
Yeah.
So is it worth jumping into how scalable compute fits into data platforms, data orchestration in general?
Yeah. Let me figure out where the Zoom thing went. I'm going to use my iPad. I've done this once before at a PyData DC meetup. And I learned my lesson that when I look down, all you see is the top of my head.
Oh.
So let me know how I'm going to move the camera. Hope that this works. How's that? I think you can still.
Yeah, that works.
Yeah.
It works well. I feel like I'm entering a Beastie Boys film clip or something.
That's a lot of pressure. Okay. It's a lot of pressure.
Sorry. Okay. Let's step back from that. Eminem.
No, it's all good. It's all good. Okay. So in enterprise data science, my perspective on this is that you've got really five-ish different axes of things that you have to care about. So there's data. I'm just going to write them all out first. There's your development environment. Every time I get on a live stream talking about, or a live, Jesus, dev. And
you're doing great.
Every time I go live trying to do this, like my handwriting goes to crap and like my brain stops working. So it really is true that like as soon as you go to a whiteboard, you lose like half of your intelligence. So there's dev, there's the scalable compute aspect. There's your workflow manager. No, come back. Workflow manager.
I love that Zoom. I know I've mentioned that before, but
then. And then there's also kind of how all of this is related. Hold on, let me. Hold on 1 second. I need to resize my canvas. Whoop.
Nice.
Great.
There we go.
Wow.
So there's how. No. All right. Sorry. There's how all of this is related to prod. Okay. So then how do you take all of this and how do you go to prod? Right? Because this is where the business cares about. Getting to prod means that you have customers. It means that you are bringing in dollars. The scalable compute piece, this is things like Spark, Dask, IPy parallel, or, that's specifically for you, Hugo.
Thank you.
I'm sure that you've done that. Then you've got like MPI, et cetera. Then there's all of the possible ways that you can make your compute faster. You've got your development environment. This is local. Things like PyCharm, VS Code, et cetera. You've got remote. Things like Jupyter, just a terminal. Then you've got kind of the, your like enterprise products. Things like Anaconda Enterprise, and I'm out of space again. I'm getting better at this though. Things like Anaconda Enterprise, things like and feel free to chime in here with other products that you guys anyways, Then you've got data. Is this S3? Is this SQL somewhere? Is this, like Postgres? Is this like a warehouse? Like a Redshift? That's an AWS product. Snowflake, Dremio, etc. Then you've got a workflow manager. These are things like Airflow, Prefect. I think Uzi's an interesting one to talk about from the Spark side. There's an ocean of these. And so the reason why enterprise data science gets so complex so quickly is that you've basically got the outer product of every single bullet here. And is like the way in which you can, and then you've also got all of this on your infrastructure. Is this AWS, GCP, on-prem, Azure, etc.
And I think this is all super important. I think the other thing to recognize is that a lot of these things, especially at big tech companies, are being built in-house as well now. And some things like Airflow then are open source, but everything from data to data end to scalable computing infrastructures, there is a huge efforts. And it is challenging that a lot of these things are being siloed within organizations as well, but they are being productionized in-house.
Yeah. Like the only way to maximize the investment in the data science teams that folks have brought on board is really to solve this problem. Is to say, here is like, you have easy access to data. We have hammered out your development environment. We know how you're going to scale workloads up. We know how your workflow, or we have a workflow manager in place, so you don't have to go, run cron on your dev VM in order to get data where it needs to go. You have solves for all of these. And then, the final piece of the puzzle is, how do you get, when you've successfully proven out there's dashboarding is this thing that kind of, it's like it sits between dev and prod, but in terms of sharing insights, there's a number of tools there for that. Anyways, I'm not gonna.
And Marius just made a great comment that historically every single data company built their own workflow manager before we had things such as Airflow, open sourced, and Uzi, right?
Marius and I worked together in ad tech, and we definitely had our own version there. It was called Streams. It was fantastic.
Yeah.
It solved the specific problem of this. Here is a thing that runs, it produces data, and you can say this needs to run on some cadence, so every hour, every 6 hours, every day, and it depends on the results of the upstream data. And so when that data that you depend on is filled in, your job runs, and when your job runs, it can kick off the downstream things that depend on it. But yeah, it was this very elegant way to solve the time-dependent data problem, which I haven't seen solved in open source yet.
Cool. And we have one other comment. Alex Remedios says, this is pure sci-fi. And I like to think that is referring both to the content and your live drawing as well. So, great. So, sorry about that. What's that, James?
Could be Eric's microphone too, which is changing colors right before our eyes.
All of it.
Oh, yeah, absolutely.
Yeah.
And Madhu has an interesting question. What about deployment options?
For which piece of the puzzle?
Yeah.
Are we talking about building the data platform? Are we talking about deploying scalable computing, deploying from dev to the workflow manager, making sure that your deployment that is a dashboard that needs access to scalable computing and data all works? What about deploying is the hardest question to answer because it's dependent so much on your infrastructure.
Yep.
It's dependent on your infrastructure, and it's dependent on the tools that you've chosen kind of throughout your data, your development environment, your scalable compute. If you can clarify a little bit, I'm happy to keep going. But
let's move on. And if Madhu wants to expand on the question in the chat, that'd be great.
Sure.
The other thing, when you mentioned dashboarding, that this brings to mind in terms of like sharing insights, is how this all relates to the decision function and decision science in any organization, which is probably for another live stream. But if decisions are automated is one thing, but if we're doing all of this to show decision makers insights and then roping all of this into the actual decision function is going to be, it is an unsolved challenge. That will be more and more important.
Can you elaborate a little?
Yeah, I mean, the fact that I know a lot of data scientists who do, use all types of stuff like this, develop dashboards, and then it's not clear whether the decision makers actually even use the output of all of this work. So actually coupling the data function to the decision-making function in a robust way.
Yeah, I mean, in many ways, like a dashboard is necessary, but not sufficient, right? Like you also need the trust between those two functions, right?
Yeah.
You need the like access, like the data scientists need access to the decision makers. The decision makers need to understand how data science works, right?
Yep.
The data scientists need to understand what the business cares about. So there's this like bi-directional education that as folks in the data science world, you rarely get, because you're so often just siloed.
Exactly.
In this like, we wave a wand at a hat and pull out a rabbit and ta-da. I mean, that's a problem that I've heard time and time again from people that I've tried to, talk to about this stuff. Yeah. Cool.
All right.
So the Dask piece, right? Dask is one component of this extremely complex system. Like, I know that Coiled, is here, and Coiled is playing in the Dask space. Like, what's your reaction to seeing this, and like where Coiled fits in here? And how?
The way I think about it is that scalable compute, in all the variety of ways that we've discussed, is becoming increasingly important and table stakes, right? So we are building products and services around that part of this particular challenge. In particular, trying to meet data scientists, data workers, machine learners, I use that term in air quotes, meeting them where they are and where they work. Essentially, so I'm a huge pain point for people working with data is being taken out of their own environments when essentially they have vendor lock-in in large organizations, and they can't really do their data work in the way that they need to. And I think Databricks does a wonderful job with a lot of things, but I think asking data scientists and Pythonistas to jump into Spark notebooks is actually really challenging, particularly when they need the newest version of TensorFlow or whatever it may be. So we're really solving the pain points of meeting data workers and data scientists and people doing machine learning where they are. Whether it be if they want to spin up a Dask cluster, scalable compute cluster from their terminal or PyCharm or a Jupyter notebook or wherever it may be, they can do that. So that's really how we feel we fit in here. And then, of course, this is still a work in progress. And so Matt has just commented in the chat, Coiled today tries to focus as much as possible on scalable compute in such a way that it can augment the other components of this chart without friction. And that's a really nice way to think about it as well.
That makes sense. Like I am a little skeptical of any platform or quote unquote platform that claims to be able to do all of these things. Right. And so
absolutely,
one of the things that I like most about the positioning of Coiled is that you're not trying to be the thing that does all of these things. It's just too complex, frankly.
Absolutely. And I think something Matt and I wrote something for O'Reilly Radar last year, slightly provocative, but the basic idea is that we feel best of breed products are going to become more and more important as opposed to these all-in-one data platforms. And we're looking for interoperability between best of breed products in these. So collaborating with other people developing products in different parts of this workflow and process in order to reduce friction between them. And that's something we're very excited about.
Yeah.
So that, I'm sorry, James, go ahead.
I was just going to say Coiled, much like Dask, interops with like different columns in this diagram, right? So like both Dask and Coiled, you can interact with Airflow and Prefect, for instance. You can also, like, we're not going to handle data management for you, but with Dask and with Coiled, you can access all of your data, say in S3 over in the data column, things like that. So the mental model is there's some overlap between Coiled and Dask there.
Mm-hmm. Yeah. So getting back to the one business risk or the one business problem slide that we had gotten to, which was risk, right? The choosing best of breed is way riskier than choosing a single platform that does it all, right? And so while, my perspective is certainly that, choosing best of breed tools makes the most flexible and the best platform for a company. There's also a ton of risk there, right? Because you need somebody who can link those all together and somebody who's got the vision of marrying the tools and infrastructure with the kinds of problems that have to be solved at a company. And there's not a lot of us around right now. And so from a risk point of view, how do you, being able to, sell into that is going to start to be challenging. Because you're going to have to, compete with we're a platform and we do it all versus we are one component of your platform. So, just an interesting kind of back to the risk point of view.
Absolutely.
Anyways. So that was the main thing that I wanted to put down on a whiteboard. And any other comments or questions in the chat?
Yeah, we've actually got a lot of interesting comments. Definitely, a lot of people feel that it's important to develop more niche products as opposed to all-in-one platforms, but agree that the de-risking there's an interesting trade-off there. Ray Bell agrees on the tooling preference of data scientists. And
Ray is actually coming to work at DTN in February.
Oh, so, awesome!
Yeah, I convinced him to join the team.
Congrats, Ray.
DTN. You hired at Scopats recently, is that right?
Yep.
Yep. Awesome. Good for you.
Hired Anthony Scopats and Ray Bell and Tim Hopper as well, if you know him from Twitter.
I do. He's even taller than me as well. And Marius has said the cost of managing a large suite of best of breed tools is non-trivial. Absolutely agree with that. But Matt's response, of course, is so too is the cost of trying to add modern workflows into your legacy Cloudera cluster. With that, that Rockland bite we all know and love.
Yeah.
You can imagine just the slight smile on his face as he types that.
I think he's cackling evilly, actually.
We need to move on, but he's also trying to recruit Ray currently in the chat. So I'm really glad you don't have access to that. Cool. So we can go a number of ways here. I'd be interested in.
I'm not going to do this again if you keep trying to poach my people, Matt.
So we could go a number of ways. One possible direction is thinking about an ecosystem comparison, which may be instructive for people here. Is that something that would interest you? Or
yeah, let me switch back to it.
I'm marginally interested.
No. Again, I'm trying to navigate a computer and decide if I'm on the iPad or Windows and whatever. Yes. Cool. So so the talk originally was trying to understand Dask versus Spark versus Rapids in the context of, what kind of tools should you be choosing and what kind of tools should you be thinking about as a practitioner in this space? And
can you just tell us what you actually, in your talk, you gave a really nice breakdown in about 3 words each of what Spark is, Dask is, and Rapids is. So could you just...
Yeah.
I can try it. I think you said something like Spark is distributed data frames
Right
on JVMs on CPU. Yeah, great.
Yeah. So it's distributed data frames in the JVM on the CPU. Dask is distributed data frames in Python on the CPU, and Rapids is distributed data frames in Python, now, or Spark on the GPU.
Yep, great.
Though the in Dask or Spark on the GPU, the Dask story is far more mature than the Spark story, is my understanding, having just talked to a couple of those folks over there like today. Yeah, man, you're like really good at cueing me to like say the things that I've said before in like a way that makes sense. So thank you, Hugo.
What I'm hearing is that you're good at your job.
Almost like he's hosting.
Wow.
Great.
I was trying to be nice, James, but thanks for making me sound like an asshole.
You don't need any help with that, Eric. No, I'm kidding. You're definitely not coming on again.
Wow. Wow, you guys are great. Thanks for thanks for the invite. I'll be sure to sign up again next week. Yeah. So I think so my perspective on this now is not Dask versus Spark versus Rapids. It's really SQL versus Dask versus Spark in terms of how do you do scalable computing in the enterprise. SQL has seen, almost a renaissance in terms of accessibility and tools. I mean, you've got Snowflake, which I don't even know what their valuation was, but it was outrageous recently. Or no, they're public now, aren't they?
Yeah. Yeah.
And aren't they at are they tens of billions of market cap or hundreds of billions of market cap? It's something crazy
like that. Yeah.
Yeah. Something bananas.
I just want to mention one thing. The Dask account on YouTube has just commented, which is a first. And Dask has said, I am more than just data frames. And so I just want to clarify, this is actually a very important point. And it is another misconception that Dask is best used for tabular data and NumPy arrays and maybe some machine learning and that type of stuff. So I think the way we like to think about it is Dask does make it very easy to do it with NumPy, Pandas, scikit-learn, but it's a lot more than that. It's actually a framework to build distributed applications that is used with a lot of different systems such as XGBoost, PyTorch, Airflow, Rapids. I think Dask really likes to be thought of as a full distributed computing toolbox that meets you where you are. So it's a bit more than data frames. I think for the purposes of this conversation, in terms of laying out Dask and Spark and Rapids, that was very good. But I did want to make that clarification. And I wanted to thank Dask for coming and saying hi. Okay, $86 billion market cap, Scott has just said in the chat.
Oh my God.
Yeah. Time to go home.
That's a lot of market cap.
It is. Sorry, go on.
Yeah, I will also freely admit I am not a Dask expert. This is entirely like my perspective as a as a consumer of open source tooling.
Absolutely.
Awesome.
So yeah, how's it look now? I love that we have our friends Blazing SQL there as well.
Yeah. So I would say that SQL, like from where I'm sitting, SQL and Dask are definitely trending positively, or they're trending up. I would say Spark is trending down. I think it's interesting to note that Databricks has even moved past Spark as its engine. They maintain the Spark API, but I wrote it down like an hour ago and I've already forgotten, but they have a new like rewritten from the ground up in C++ engine that they use to power workloads on Databricks, which is interesting, right? So like people are already looking for, what comes after Spark. I think two safe choices at this point are, would be Dask or SQL via, a Snowflake or a Blazing SQL or a thing of that nature. And where does Rapids fit into this ecosystem now? Powers all of them. In 2019, I think the positioning of Rapids was that it was going to be another end user facing technology. My understanding is that they're starting to, or have already started, or have already done the work to reposition Rapids as just a backing engine for SQL, a thing that makes Dask faster, a thing that makes Spark faster. So that was a tectonic shift in my understanding of how Rapids fits in here. And that was like 2 hours ago. So I don't, I'm still trying to like orient in this new world.
And for context, everyone, Eric pinged the Rapids team, was like, hey, I'm doing a live stream with Coiled. Soon can we talk about what Rapids is today? Which is awesome. I want to pick James's brain about Dask and SQL.
I actually have a quick question before that about, so like, I know you just spoke with them, Eric, but like, so I mean, what you're saying is no longer, it's positioning itself to not be a user-facing, project? Like, what exactly does that mean? That you're just going to be interacting with Dask sort of purely, and you might have a data frame that's a Dask data frame that's backed by like QDF data frames for each partition? Is that like?
Yeah, that's my understanding.
Cool.
So the goal is not to expose QDF directly, but to use the Dask data frame, which then can leverage QDF if it needs to.
Yeah, very cool. And actually, I think Eric had a slide, if I'm not mistaken, speaking about Dask and SQL. A couple slides down or something like that, if you wanted to jump ahead.
This one?
Yeah.
Yeah, let me come back to that one. So trending up or down, right? I think this is reflected in the Stack Overflow developer survey. If you look at the kind of, I believe this is actually other frameworks in terms of the developer survey. Pandas is, Pandas kind of as a proxy for Python, right? So Pandas is trending up. I would hazard a guess that whenever Pandas trends up, Dask, I think Pandas trending up is a leading indicator of Dask trending up. I'd feel free to correct that hot take, Hugo or James or anybody in chat. TensorFlow.
When you say like Pandas 2019 was 12.7%, is that 12.7% of like new tags or new questions or something like that, or?
Of what I believe this is what the folks who answered the survey said that they use.
Gotcha.
And so this is I think the numbers were like on the order of like 10,000 software professionals.
Awesome. Okay, thanks.
Yep.
Yeah.
And the other thing I just wanted to mention, Jim Christ has a great question in the chat about other distributed Python things like Ray. And Ray Bell actually responded somewhat to that. Different Ray to Ray. We're overloading Rays currently. But Ray Bell mentions that there's an explosion of distributed Python things for quote unquote AI, right? So Horovod, PyTorch Lightning has its own thing going on. So there is actually, outside of, your classic data science stuff that we're talking about now, such as Pandas, in the quote unquote AI space, where we are seeing a huge proliferation of tooling there as well.
Yeah, I mean, all of these frameworks are interesting, and they've all got like a very clear use case. But in terms of general applicability towards like, I am trying to I'm trying to improve the quality of data science at this company, or, this company needs to begin its data transformation to, join the 21st century, to join like the modern tech world. And we have to bring data science to a company. Like the long tail of like frameworks isn't an interesting question in that context. It's absolutely. Like it's only useful and it's only interesting when you already have a team of expert people that have data science stuff running in production, and you're encountering that specific problem that Horovod solves. Like Horovod, I believe, is the like distributed GPU training thing that Uber wrote, right?
Yes, that's my understanding.
Yeah, and like you're not going to go from like, cool, we we dumped data out of our SQL database to, I need to use Horovod. So all of these tools are relevant to different areas of the spectrum. The part of this that's most interesting to me is like the part of how do you get off the ground? And so, I have little opinion on the Ray and Ray the framework, not Ray Bell. Ray and Horovod. They're like things that I'm aware of, but not things that I encounter in a day-to-day.
Great.
How about you guys?
Look, I agree completely, and it suits my purposes as trying to market Dask as well. So, but let's move on in the interest of time.
Sure. Yeah. So another interesting note: SQL is trending up, Python is trending up. R is, I would say that's flat. I would not say that's trending down. I'm sure that the error in this is not less than 1/10%.
Yeah, and R is full of statisticians who would talk about statistical significance with this as well. So,
just going to punt on that entirely.
Stack Overflow. We want the p-value. No, I'm kidding. We want we want a Bayesian posterior bloody what? Okay, let's go on.
Yeah, and then you've got Scala, which is also trending down. I am using Scala here as a proxy for Spark. Oh yeah, sorry. On the frameworks one, Spark and Hadoop are both trending down. So, I'm not sitting here, pulling these numbers out of my thumb. And then I think another interesting way to look at this ecosystem is, what is the interface that you're going to use, right? Are you going to use SQL to interact with data, or are you going to use the programmatic interfaces? That's probably the largest way to segment the population here. If you use SQL, then there's all kinds of new tools that are coming up. You've got Blazing and Snowflake. Spark SQL, again, talking with the Rapids folks, their perspective is that Spark SQL is definitely, people are leaving Spark SQL for things like Presto and Snowflake. And then, of course, for folks that know SQL but are trying to get over to the programmatic way to interact with data, there's this, I'm not going to say new, but I would not call it mature yet. Please feel free to augment that with better knowledge, James or Hugo. But Dask SQL is definitely a thing that I think has made a lot of strides in 2020.
Yeah, I'd agree with that assessment. Yeah, I was excited to see that you included it here. So just for anyone watching, if you're interested in Dask and SQL, I'd recommend go checking out this project from Niels Braun.
Yeah. And then as you go over to the DataFrame side of the world, right, then it rapidly bifurcates into pandas versus Spark. You've got this kind of oddball library that the Databricks folks launched 2019, I think at PyData New York in 2019. They announced Koalas, which is the Pandas API onto the Spark DataFrame, which is, a strange, I think every single one of the libraries that is like, we're basically pandas, but not, all have kind of somewhat unexpected APIs, or like the library doesn't behave exactly like pandas. I mean, it does for the most part, but there's some strange edge cases.
I have a few issues with koalas, but I think the main one is that I'm Australian.
Glad you got that in, Hugo. I'm glad you got that.
I had to. Thanks. Here every week.
Now, is that because you don't like koalas? Like, do you not like koalas because you're Australian?
No, this is like some form of probably to use modern buzzword-laden terminology, this is some form of cultural appropriation of my motherland by an enterprise. Okay, sorry, let's continue. I don't want to diverge too much.
No, it's all good. And then if you want to accelerate pandas or Spark, you've got a few options. Spark on Rapids is a thing that is, I don't know how long it's been under development, but it uses the same. So this is libqdf is the C++ implementation that I think sits on top of, CUDA or some flavor of that. So it's like a JVM wrapper around a C++ library that then can be used to accelerate Spark. Going kind of down the same chain on the Panda side, you would first go to the Dask DataFrame to get it into a distributed format. And then cuDF can be used to accelerate Dask. And then that is the Python wrapper around the same C++ library. So these things both kind of join back at the bottom with the Rapids team. I should box that in a little better. So all of this is Rapids. Oh, come on. The key bindings are different. Send to back.
Great.
Again, live PowerPointing.
They said it couldn't be done.
They said, why would you do it?
Yes, that is what they said. If you're gonna, you should make it purple, I think.
What?
This is harder than live coding.
There we go. Yeah.
There we go.
Here we go.
Cool.
It's the wrong hex, but if you have that live, I'm happy to change it.
Just over 5 minutes left.
Sorry.
And I am interested. I am interested in something that was in your PyData talk that I thought was really nice was a kind of a comparative analysis of things in the landscape. And it would be interesting to kind of go through that.
So this talk was originally done in Keynote, and I had exported it to PowerPoint so that I could actually use it on my desktop at home. So the scaling got all wonky. But yeah, so
I'm looking at your speaker notes as well. I love the two words dense slide.
Yeah. Well, I think I literally wanted to put that in here so that I would say it during the talk and acknowledge that this is a lot. I know. Yeah. So I added the December 2019 here and the January 2021.
Mm-hmm.
I think, again, the big takeaway here is that Rapids is no longer a thing that you should use to differentiate between or in the Spark versus Dask versus Rapids world, because Rapids aims to just be an acceleration engine for both of them. So that's a huge takeaway. And then kind of the things that I've highlighted are the things that I think are noteworthy to talk about, kind of the December 2019 versus January 2021. Again, so the Spark DataFrame API got koalas, which is, an interesting call out, right? To make it a little more accessible to the Python folks. I would say the Dask maturity story has changed dramatically. I think that there's 3 companies now that I know of that are offering services in the Dask world, right? So there's Coiled, who I'm on with now. Hussein Sultan, who some of you know, is running data science at MetroStar Systems. So they're building, they're aiming to bring the PyData stack, including Dask to the government space. I know that NVIDIA is ramping up their professional services in the data science space. There's QuantSight, there's Saturn Cloud. I don't know of any other, and there's Prefect, which I think has pretty Dask native as well.
Yeah. And we work them as well. We've done a bunch of live streams with them also. So yeah, they're really cool.
I think job scheduling for Dask has made some huge strides. I think Dask Kubernetes has come a long way. I think it's seen some substantial adoption there. So that's probably the big thing, since Kubernetes is eating the world. A better Dask story on top of Kubernetes is definitely worth calling that out too. I think local scalability has also improved quite a bit with Dask, predominantly because of Rapids. Hey,
and Hussein jumped in the chat and said, "Hey, y'all."
Oh, look at that! What's up, buddy?
Yeah. And I just want to say the Kubernetes story is something we're working on actively at Coiled, aren't we, James? So that's a space to watch.
Is that to be able to use Coiled as a like a way to provision Dask clusters on Kubernetes?
Exactly.
Kind of like you're doing now with Dask on ECS.
Mm-hmm.
Yes.
Nice. Is that going to be on-prem, on cloud?
Yes.
How are you guys going to?
Yep, both.
Mm-hmm.
Okay. And then SQL, right? So you've got Dask SQL, which is a big change from 2019, where I believe the only thing that you could do is like materialize an entire table in memory with, I think, dask.read SQL, which was really just give it a table name and a connector, and it would turn your table into a Dask data structure. So those are probably the big call outs. I still don't know anybody that, sorry.
I was saying, you mentioned Dask Gateway was starting to be developed whenever in your previous talk in 2019. And I think it's caught on with like Pinju's using Dask Gateway, for instance.
Yeah, I'm looking forward to being able to use either Dask Gateway or Coiled at some point in the future. Once we reach that point in our evolution here at DTN, we're still, we have to crawl before we can walk, right?
Exactly. And the other thing was actually where my mind went was just thinking about looking at visualization, for example, the fact that Dask taps in to the Pythonic visualization ecosystem, right, is so powerful.
Oh my God, these slides are awful. So sorry.
That's cool. There you go, exactly. And this speaks to a broader point, I think, of how Dask does interoperate with the entire Pythonic ecosystem and is native for Python users, which is what first attracted me to the project, actually.
Mm-hmm.
This
is a huge win, just being able to tap into this directly. And, I think if I was going to expand on that a little bit, it's not just the visualization, it's also the dashboarding piece. Because the visualization is really nice kind of for yourself, but being able to also use some or many of these visualization tools in a dashboarding framework and also have it use Dask under the covers is an amazing kind of confluence of tooling that lets you scale kind of out of a notebook and into a dashboard very, very easily.
So we have around a minute left. We can go a bit over. I'd just like to open the space for any final thoughts you may have, Eric, or what you're excited about or nervous about in the space, or what the ideal future looks like for you. Those are a bunch of very broad questions and ideas.
Yeah, so my area of focus is really predominantly in the how do you move the needle on bringing businesses into the data science revolution, right? And so the tooling and the infrastructure and the knowledge is all there. The tools are sufficient, right? You've got Jupyter Hub, you've got Dask, you've got all of these Python tools, they're all good enough. The hard part for kind of that Fortune 200 to Fortune 5,000, that mid-market space is how do we use these tools to solve the business problems? And I've spent the last, couple years at Anaconda and the last 8 months more recently at DTN, just being exposed to the business problems, which has just been so interesting to see. It's not a better library isn't going to solve the problem, right? Because you need to teach product how to think about data science, and you need to teach data scientists how to talk to business folks.
Yeah.
There's a baseline competency that you need. And then the next step there is transforming the whole business to be able to speak data science, and then I think at that point, after you have products in production that are powered by, whatever models that your data scientists have chosen, then you get to start to explore that long tail of, like really cutting edge tooling.
Great. I couldn't agree more. And this reminds me of something Brian Granger said at the first or second JupyterCon. He gave a talk in which he was talking about institutional adoption of open source tooling. And he framed it as a classic physicist, he framed it as a phase transition where we're going through, in which previously organizations were full of individuals using open source tooling, right? And now we're entering a phase in which we actually have organizational and institutional adoption of open source tooling. And it isn't clear yet what we need in order to support institutions at scale doing that. And that's one of the reasons for being for Coiled. And one of the reasons I was really excited to join Coiled is in the next stage of OSS adoption at a large institutional scale, being part of that in projects we all believe in. We believe provide utility in the Python space in particular. Mic drop.
I mean, that was a great mic drop.
Yeah, I really need to get a mic. Like, you couldn't even drop that though, so you need to hold it. But I just want to thank everyone.
I could like push it down, mic drop.
Yeah, I like that a lot. I'd love to thank everyone for joining. Thank you, James, for co-hosting. Eric, I always find your talks and our conversations so clarifying and thoughtful. So thank you so much.
Yeah, thank you.
It was really fun. I appreciate the opportunity to come and talk to you guys.
Absolutely. And also the chat in the chat was great, and to see a whole bunch of people in the space come out and be thoughtful and ask interesting questions. So thank you all. And we look forward to collaborating with you in the future as well, Eric. You're like, maybe. Just kidding. Great. All right. Thank you all for joining. We're going to do a recap post soon. If you're interested in seeing what we do at Coiled, please go and check out cloud.coiled.io and spin up some CPUs, Dask clusters, GPUs on us for the time being. My sales lead's going to shoot me in the foot. But please,
that's going to be expensive.
Come and check out our product. Don't be mining too many Bitcoin. And we'll see you on our next Science Thursday next month. Oh yeah, no, the final thing, of course, we actually have our first Coiled webinar, which isn't a Science Thursday. It's a webinar in 2 weeks on at scale hyperparameter optimization and doing machine learning faster with a package called Optuna and Dask. With a wonderful individual called Chrisman Loomis, who works on this, and James as well. We'll be showing how Dask and Optuna are integrated for all types of stuff across from finance to healthcare to deep learning. It works with PyTorch, all of these things. So definitely follow us on Twitter to get that announcement and so forth. Cool. All right. Thanks, everyone. Thanks once again, Eric, and we'll see you all soon. Ciao.